Let's take a look at prime factorization. Here's a definition for you. Take a moment to write it down. Prime factorization, an expression written as a product of prime numbers. We have these three numbers here, and I'm going to go ahead and write down the prime factorization of each of these numbers. The prime factorization of 14 is 2 times 7. And then so 2 times 7 is an expression and is a product, multiplication problem, of prime numbers. 2 and 7 are prime. 21, for the expression for 21, the prime factorization is 3 times 7. Again, 3 is prime, and 7 is prime. The prime factorization of 30 is 2 times 3 times 5. 2, 3, and 5 are all prime numbers, and that's the expression. It's written as a product. You'll notice for this last one here, for 30, 2, 3, 5 are in order. And that's another important thing with prime factorization. So how did I get these? Let's take a look. The way that we figure out these prime factorization is that we need to know our primes to begin with. Say them with me, primes. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 are just some of those prime numbers that we might need to know so that we know that we are done figuring out our prime factorization of any given number. So if I was given a number 30, all we need to do to find that prime factorization is to make a factor tree for 30. To make that factor tree again, maybe you have seen that video already, maybe you haven't or understand this, just to remind you, we think of a math fact for 30. And then so I could think of 5 times 6, because 5 times 6 does equal 30. Now 5 is already prime, so I bring it down to my next level of my factor tree. 6, even number, can break down to 2 times what? 2 times 3, right? And then so we have 5 times 2 times 3, which are all prime. So we know that we are at our lowest level of our factor tree, and our factor tree doesn't need to grow anymore. All we need to do now is we need to list those out. Whoops. We need to list those out so that we know our prime factorization of 30. 30. And this is the prime factorization. 2 times 3 times 5. And there we go. Time for you to try. All right, it's time for you to try. I want you to find the prime factorization of these two numbers, 16 and 45. Go ahead and hit pause. We do start with the factor tree. I know that 16 breaks down into 4 and 4. I know my factor tree is not done because 4 is not prime, and we can break down into 2 and 2. 2 times 2. So my prime factorization of 16 is 2 times 2 times 2 times 2. And if you know your exponents, that's 2 to the 4th power. That's our prime factorization. I would have accepted this as an answer, right here. And I would have accepted 2 to the 4th power as an answer as well. All those 2's are already in order. With 45, we think of a math fact. We can break down 45 in 2. I can think it's divisible by 5. So I'll go 5 times 9. 5, it comes straight down because it is already prime to my next level of my factor tree. And 9 breaks down into 3 times 3. I'll put in that multiplication sign there. And then I list them in order. 3 times 3 times 5, which is our prime factorization for 45. With exponents, that'll be 3 squared times 5. Don't worry too much if you don't know this yet. We'll see that in another video. Just one more note for you before I let you go today. If a number is prime, then it can't be written as a product of primes. So remember, 1 is neither prime nor composite. 1 is neither prime nor composite. That means our prime numbers, like 5, hey, we can't write anything times. You can't say 1 times 5. Can't say 1 times 5. Our prime factorization of it, there's nothing that we can multiply together prime-wise to get 5, just like there is nothing that we can multiply together to get 23, so it can't be written as a product of primes. There is no prime factorization for it. We just call those prime numbers. So those steps again to figure out the prime factorization of a number, all we need to do is we need to break down that number into an expression of just primes. And so the way we do that is we use a factor tree. And we go step by step until we get all primes in our factor tree. And then we don't know that there is our prime factorization, and we do list them in order. 2 times 2 times 2 times 5. With exponents, this would be 2 cubed times 5. And this here is our prime factorization of our number.